Hello, and welcome to Kill Bill. Revenge is a dish best served optimized. What a title. No Uma Thurman either. I know some of you might have been expecting that, so it's just me and a very interesting use case of GenAI to share with you all. Now, before I proceed further, I just wanted to recognize someone. Ryan is a lead AI engineer at Sportsbet. He was instrumental in bringing Kill Bill to life. Unfortunately, because of logistical reasons, let's just leave it at that, he couldn't make it over here. So I get the pleasure of sharing his amazing work with you all. I'm Abdul. I'm an engineering manager at Sportsbet Australia. Cool. Picture this. Reducing your costs while simultaneously maintaining your performance. Sounds like a pipe dream, doesn't it? But for the next 15 minutes or so, I'll show you how we leverage the power of GenAI, build intelligent workflows, and totally changed our approach to cost management. But before we dive into the details, a little bit of who we are and our journey with Databricks and data as overall. Sportsbet is Australia's leading online wagering bookmaker. We handle about 4 billion price updates every year. During Melbourne Cup, what we call as a race that stops the nation, we peak at about 63,000 bets per minute. We also have a fairly large active customer base, a little over 2 million who place a bet with us year on year. What basically all these numbers mean is essentially the vast compute that's required to process the data that comes through, right? And as you can imagine, even small inefficiencies can cause a lot of cost, can have a lot of cost implications. So our journey with data is no different than many organizations. Just like everyone else, our platforms were, let's just say, very traditional in nature, and they had lots of challenges, right? We went through a period of modernization, and migrating our platforms onto Databricks was a huge milestone for us. Post or during this migration, our main focus essentially was, apart from investing in our people so that we leverage modern data practices, was essentially agility, scaling our platforms, performance, and most importantly, meeting our SLAs. So our data platform is built entirely on Databricks. Now, I won't go through the architecture detail there. That's probably for another time. But some of the key things I wanted to highlight was, so we achieved less than 10-minute latency. Operations became very boring because we freed up a few of our people from mundane tasks. We increased and delivered speed in our delivery as well, and things were looking brighter and brighter. But here's where our story gets interesting, right? So as we scaled, we faced a very classic dilemma. So our resource utilization was growing a lot faster than our workload, essentially. Sure, we could throw a lot more compute at the problem and solve it and still meet our SLAs, but was that cost necessary? Were we doing things the most efficient way, or could we do things better? Those were the questions we were asking ourselves. But we also realized was the problem ran a lot deeper, more than just high costs, right? Like you see, we've got fairly large spread of data engineers, data science, and ML engineers within Sportsbet, and they're essentially spread across multiple teams and multiple geographies. Now, as you can imagine, like configuration drifts or misalignments between the teams, can have a lot of tech debt, and what it led to was essentially our engineers spending a lot more time in optimizing pipelines than actually building new features, which isn't really good for business. So obviously, we wanted to take a newer approach, and we needed something, an automated way to solve this. So enter Kill Bill. Think of it as an intelligent advisor that analyzes everything from, let's say, logs to your code patterns, and makes optimization suggestions while maintaining or improving your performance. We essentially tried to build this to bridge the gap between what's possible and what's practical, right? Like in its first application, essentially, we were able to reduce the cost of a particular job from about 192,000-ish AUD, not USD, down to $98,000. So that's nearly 50% reduction. So why Kill Bill? Like, why not just do our traditional cost optimization? The answer basically lied in the need for automation and also better use of our people. Let's face it, like we've all been there. Nobody really likes scanning through pages and pages of logs, dive into resource utilization or specs and things like that, or even go through lines and lines of SQL code and try to fine-tune a SQL query. It takes a lot of time and a lot of effort, and it's not an easy job. A lot of senior engineering teams also sometimes struggle with this, right? Cool. So with the growing advancements in AI and specifically in generative AI, it seemed like the most appropriate solution to go after. It essentially could recognize massive patterns across massive data sets, process years and years of historical data within minutes, and continuously learn from a lot the new deployments that we were doing. All right, with all that out of the way, let's talk about the details of Kill Bill. So at a very high level, we can categorize it into 3 logical layers. So the application layer, where the UI sits, where the engineers or the users can interact with it. The agent layer for essentially your AI analysis, and your infrastructure layer, which is literally everything from the LLMs that we use, MLflow for monitoring, etc. Here's what the high-level architecture looks like. The system essentially integrates 5 key components. So the interaction layer, which is the chatbot UI that I mentioned, and data sources. This is essentially where we gather all the information that is needed by the system to function. Next up, down below, it's kind of hidden by the text, but that's the knowledge base. Essentially, we create a comprehensive vector database using some of those data sources. And on your right, the GenAI component is all the models that we use, MLflow, et cetera, right? The last bit, which is the most important one, the agents, this essentially is your optimization brain. Let's break this down one by one. All right, talking about data sources, so we gather data from literally everywhere. We run a job on a cron scheduler to crawl internet for Databricks best practices, and also from Databricks website. We also supply it or supplement it with our own internal documentation and the learnings we've had, fine-tuning pipelines, et cetera. We also use some system tables that give us DBU, billing usage, et cetera. We also configured Overwatch data so to get all the metrics details and Spark config and other things. Some metadata bits already, as you know, would exist in Unity catalog that we use. Cool. The next step, and this is probably the most important thing as well, was to create a comprehensive knowledge base. So essentially, our job pipelines uses those data sources or some of those data sources, like I mentioned, and takes help from the Hugging Face embeddings model, and we index all of those embeddings into the vector database using Mosaic AI vector search. This was very important for us because we didn't because the alternative was like you need to end up writing all the rules for the decision making, right? So we didn't want to do that. So we wanted the system to understand why certain best practices work better than the others. So we incorporate all Databricks documentation and best practices, but here's the key, like we also supplied internal documentation, right? So that makes it a lot more comprehensive. So the challenge was making this knowledge base actionable. It's not enough what type of configuration works is best practice. We needed to understand when to apply in certain situations. So these are the main GenAI components that we use. So Mosaic AI vector search, as I mentioned, for vector database, the AI gateway to interact with LLMs, and we underpin all of this with your Llama index workflow, and also ML flow for monitoring and tracing purpose. Right, so at Killbill's core, we've got three main agents. So there's a code base analysis agent and a resources analysis agent, and kind of like a main agent that sits on top that kind of mashes everything together, gives you a comprehensive analysis. We'll break this down further. All right, so code base analysis agent. So this performs code base analysis to identify any outdated code out there and also any suboptimal implementation of your SQL or PySpark. It also examines the underlying tables that the code has access to, and it extracts the metadata real time to better understand the context and provide more targeted sort of recommendation, right? And this bit of context awareness is what we think gives us an edge over with this implementation, right? So for example, like let's say we're analyzing a query that has multiple joins across multiple tables. It just doesn't evaluate syntax and other things are checks and balances are right. It extracts things like the table size, the distribution pattern, the query pattern, or the frequency of queries, et cetera, gives that context back, and then supplies you an optimization suggestion, like maybe in this case, a broadcast join isn't good enough, and you need to do a repartitioning or redistribution, et cetera. The next one is your resources analysis agent. So as you can see, it's more on the compute side of things. So the system conducts CPU, memory, DBU consumption analysis to determine whether jobs are more CPU intensive or memory intensive, right? So it evaluates cluster configurations. It assesses jobs properly if the job is properly configured based on the code that we supply it. Additionally, it also goes through Spark logs and pinpoints any section of the code that may be causing any processing delays, right? So this analysis is critical because typically what you find is when somebody is implementing migration programs or anything like us, meeting our SLAs or sticking to them is very high priority, right? So and what we end up doing is over-provisioning for things where sometimes it may or may not be necessary to do that just because we're cautious. And going through this is a good exercise to achieve better configuration. So the job analysis agent, like I said, sits on top of both. So you might be wondering, why is this important? Essentially, think of it like strings, right? Like you pull one, the other thing breaks. So this analysis kind of brings everything together and gives you a more comprehensive or a holistic approach. So I've got a 5-minute signal, so I'll hurry up. So I'll keep this one brief. It's just the UI layer, and any questions I can answer on this a bit later. So under the hood, so this is what a typical workflow would look like. I won't go through all of this again, but I just wanted to highlight that the agents obviously aren't very strict. Like, you can expand this. We are thinking about like a document analysis agent, which is specific to answering best practices, which may or may not be related to your pipeline, which might be helpful. All right, this is one of the case studies or one of the jobs where we asked KillBill to optimize. It pointed out 3 main issues with the job. So the cluster that it was running on was very memory optimized, while the workload was telling us that we needed a more CPU intensive. We were using very deprecated join patterns, which was causing a lot of shuffling in the data. And also, our partition strategy was not the best for those tables that were being used. I'm not sure if you can see the text, but that's what the analysis looks like. So KillBill provided suggestions for each of the section, and ultimately it gives you like a comprehensive report. And in reality, you could ask follow-up questions and then try and inspect for any particular area you wanted to, and then gain a bit more deeper insights into the problem. So in the end, this is what the results look like. So like I mentioned in the beginning, so the cost dropped down for this particular job nearly 50%, and we kind of maintained the execution time as well, so which was a really good outcome for us. Cool, which brings me to my last slide. So what's next for KillBill? Well, we are looking at trying to make it as autonomous as possible, so it can continuously monitor jobs and make recommendations. But we're also looking at more a end-to-end approval flow, so that, let's say you ask a question and it'll log the recommendation into a Delta table until someone goes in and just verifies or follows your change management practices and approves the CR and implements it. And then the whole pipeline can actually make the changes into your Spark configs, et cetera, automatically, right? And on that, so we're also heavily indexing on trying out for Spark configs rather than just the cluster configs, et cetera. Beyond that, really, sky's the limit. Like, we're at one point thinking about having in Databricks Marketplace, so it's more shareable, or have it open source as well. But the concept really is that, like, leveraging GenAI, sort of giving it that power to understand deeper knowledge and give us insights readily on our pipelines. With that, thank you so much for taking time and listening to the talk, and please do complete the survey.